We are starting a deep dive into Terraform, which is arguably the most important tool in the modern cloud infrastructure management. You are here because you know that managing cloud resources manually just doesn't cut it anymore. Terraform is the solution that transforms infrastructure management from a manual core into a scalable, reliable process. Think of it as a language you use to talk to the cloud. Over the next few minutes, we will cover what Terraform is, why it is essential for any serious DevOps engineer, and how it completely changed the way we build and maintain cloud environments. So, what exactly is wrong with old way of doing this? Before tools like Terraform, we manage infrastructure manually, clicking through Cloud Console to set up servers, networks, and databases. This approach creates a massive problem that prevents us from scaling. First, it's slow and insufficient. Every time you need a new environment, you repeat the same tedious manual steps. Secondly, it is incredibly error prone. Human mistakes are inevitable, and a single misclick can lead to major downtime. But the biggest issue is the lack of repeatability and the history. If you cannot recreate the exact same step twice, you have inconsistent environment. And when something breaks, you have no audit trail. The solution to the manual chaos is infrastructure as a code or IAC. This concept is simple to revolutionary. We treat our infrastructure exactly like software code. Instead of clicking around in a console, we write configuration files that define our entire infrastructure stack. This code is then stored in Git, which immediately gives us version control. We can track every change, see who made it, and roll back to a previous working state instantly. This is a huge advantage. Furthermore, ISC enable collaboration. Teams can review infrastructure changes just like they review application code, ensuring the quality catches the errors before they hit production. By adopting IIC, we bring software development best practices like code review. Terraform is the industry leading tool for implementing infrastructure as a code. It was created by the HashiCorp. It is the powerful because it's multi-cloud. You write your configuration once and the Terraform can deploy it to the AWS, Azure or GCP or hundreds of other service providers using the same workflow. This is a game changer for organizations that use more than one cloud provider. Terraform uses a declarative syntax, which is key. You do not write a script of steps to follow. You simply describe the desired end state of your infrastructure. You tell Terraform, I want a server, a database, and a network, and Terraform figure out the exact steps needed to build it. Moving from manual chaos to the automated consistency is where Terraform truly shines. Terraform directly addresses them. In the manual approach, there was no version control, meaning every change was a risk and impossible to track. With the Terraform, your infrastructure is a code stored in a Git, giving you a complete auditable history and the ability to roll back any mistake. Another major problem was inconsistency environment, and it works on my machine scenario. Terraform solves this by making environment reproducible. You can spin up identical development, staging, and production environments in minutes, eliminating configuration drift. We have established that the Terraform brings consistency and auditable to the infrastructure management. Now let's look at the simple, predictable process that makes this possible, the Terraform workflow. These four steps process ensure you always know exactly what changes are being made before they happen. It starts with the write phase where you define your desired infrastructure in a configurations file. Next, you run Terraform init. This command is crucial. It initializes the working directory and downloads the necessary provider plugins, connecting with your code to the cloud APIs. And the third step, Terraform Plane, is your safety net. It analyzes your code and the current state of your infrastructure, showing you the details executed plane. And then the final stage is to apply these changes to your cloud. The workflow we just described is powered by a few core components working together seamlessly. Understanding this infrastructure is a key to troubleshooting and scaling your Terraform usage. The entry point is the Terraform CLI, the command line interface you use every day to run commands like init and apply. The CLI takes your configuration code and interact with the next component providers. Providers are essential plugins. They translate your generic Terraform code into specific API calls for AWS, Azure, or whichever cloud you are targeting. They are the bridge to the cloud, and the resources are actual infrastructure objects you define in your code, your servers, your databases, or a network. The architecture relies on configuration files. This is where we introduce HCL, the HashiCorp configuration file. The key takeaway here is that HCL is designed by the human readable, make it easy for you to write and maintain infrastructure definitions. Your entire infrastructure is defined in a simple text file with .tf extension. HCL uses a declarative syntax, which is a fundamental concept in a Terraform. You don't write a script of steps to follow. Instead, you declare the end state you want. You simply say, I want a AWS EC2 instance with these specifications, and the Terraform figures out the necessary steps to make it happen. The code is organized into a clear structured blocks like provider and resources. Provider and resources are the two most fundamental concepts you need to master when writing Terraform code. Providers are the essential bridge between your configuration and the cloud platform's API. Whether you are targeting AWS or Azure or Kubernetes, you simply specify the corresponding provider and the Terraform uses that plugin to communicate with the cloud. Resources are the actual building blocks of your infrastructure. Every single component you want to create, a virtual machine or a storage bucket or a network, is defined as a resource block in your code. We have talked about the resources and the providers. Now let's discuss the most critical concept for the team's collaboration: state management. The state file is a Terraform's memory. It tracks every resource it has created, mapping your code to the real world infrastructure in the cloud. Without this state file, Terraform would not know what it managed. It would try to create everything from the scratch every time you run apply. This is why the state file is so important. For a teams, you must use remote state. Storing the state file locally on your laptop just won't work when multiple people are making changes. You need to share backend like S3 or Terraform Cloud so everyone sees the same single resource of truth. Now that we understand the core concept, let's focus on essential commands that form the daily Terraform workflow. There are four commands you need to master. First, we have init command. You run Terraform init to prepare your working directory. Next, this is the most important safety step, is Terraform plan. Plan shows you exactly what changes Terraform intended to make before it touches your infrastructure. You should review this plan every single time. Only after you are satisfied with the plan do you run Terraform apply. Apply executes the plan, creates or updates your resources to match your code. Finally, Terraform destroy each and every resource which has been created via Terraform. So we have covered the basic, and now we can see how Terraform fits in the bigger picture of modern DevOps. Terraform is a central piece of the puzzle. It allows us to integrate infrastructure changes directly in our CI/CD pipeline. This means infrastructure provisioning can be automated, targeted by a simple code commit, leading to consistent deployments, a much faster time to market. Terraform enables a true GitOps workflow for infrastructure. We treat infrastructure code just like application code, using pull requests and the code reviews for every change. This provides a full audit to trail. We treat infrastructure code just like application code, using pull requests and the code reviews for every change. This provides a full audit trail and the make rollback simple and predictable. The safety feature is Terraform like the plain command allow us to manage